Hello students. Today's point of discussion is epimers of glucose. Now epimers are the diastereomers which differ in configuration at one of the chiral centers. It means that we know very well that glucose contain four chiral carbon atoms or chiral centers. So among those four, if the diastereomer differ in the configuration at one of the chiral centers, then those are said to be epimers. Now let's discuss the epimers of glucose. Now, very first epimer I would like to introduce is the mannose. Now remember, mannose is the C2 epimer of glucose. What it means? Mannose has different configuration at carbon number 2. Now we know very well that glucose can be given in this manner CHO. Now this is the second carbon CHOH. This is third one CHOH. This is fourth CHOH. This is fifth CHOH, and this is sixth one. Now remember, this is the D-glucose. This is D-glucose, as this resemble the D-glyceraldehyde. Now, as far as mannose is concerned, it happens to be the C2 epimer of glucose. What it means? So first chirality center of the glucose happens to be the second carbon. In case of mannose, what happens? OH group is present on left side, and in glucose at carbon number 2, OH group is present at right side. That is the difference. So remember, mannose can be drawn in this manner. This is the carbon number 2, and configuration seems to get changed at this carbon, and rest of the carbon atoms have same configuration as that in glucose. So 1, 2, 3, 4. This is none other than the fifth carbon, and this is sixth one. So this is the D-mannose, which happens to be the C2 epimer of glucose. It means that the configuration at second carbon seems to get changed. Now, question is how to draw the cyclic structure of mannose. Now, pyranose structure for mannose can easily be drawn using Haworth projection. So, what we need to draw? We need to draw six-membered heterocyclic ring, oxygen at the right corner in this manner. Now we know very well the carbon adjacent to the oxygen is anomeric carbon, and that happens to be the first carbon. This is second, very crucial. In this very case, this is third. This happens to be fourth. This is fifth. Now, as far as first carbon is concerned, if you are drawing alpha anomer, then we know very well OH group is at right hand side, so it should be indicated in downward direction. And remember, in mannose, configuration at second carbon seems to get changed. Thus, OH group comes right here and H to the down. Now, OH, H, H, OH, CH2OH, as we are dealing with the D series, so it should be written on the upper side. This is fourth, and this is fifth, and this is sixth carbon as well. So this is the structure of alpha D mannopyranose. So remember, this is alpha anomer, so it is alpha D mannopyranose. So as it is pyranose structure. Now, how to draw the beta anomer of it? We know very well in beta, anomeric carbon consists of OH on left hand side. So we need to indicate this OH on upper side. So have a look at this. This can be the cyclic structure of the beta anomer of mannose. So remember, this is beta anomer we are drawing, thus OH should be written on the upper side of the anomeric carbon, and as mannose is C2 epimer, configuration at second carbon should get change, say then this is about fourth carbon, this is fifth one, and OH, CH2H should be written on upper side as we are dealing with the sugar of D series. Now this happens to be the beta anomer of what? Mannose. So this is the beta D mannopyranose as we are dealing with pyrano structure. So this is nothing but the first epimer of what? Glucose. Now let's discuss C3 epimer. This was the C2 epimer of glucose. Now remember, C3 epimer is the epimer which has the different configuration at carbon number third. And remember, C3 epimer of glucose is popularly known as allose. So let's discuss allose. It is none other than C3 epimer of glucose. Now we know very well the open chain structure of glucose can be drawn as this happens to be second carbon. This is the third carbon, very crucial in case of allose. This happens to be the fourth. This is fifth one, CHOH and CH2OH. Remember, this is the D-glucose. This is D-glucose. So, in case of allose, what happens? Configuration at third carbon get changed. So, first, second, third, this carbon. In case of glucose, OH group is present on extreme left. And that in allose, OH group is present on right side. So how allose can be drawn? Have a look at this. This happens to be the second carbon. It remains intact. And this is the third carbon. And at this very carbon, configuration seems to get changed. This is fourth. This happens to be the fifth carbon. And this is none other than the sixth carbon. This is D-allose. So this is the difference in between allose and glucose. So remember, allose happens to be the C3 epimer of glucose. Now let's see how cyclic structure can be drawn. So we will try to draw the pyranose structure of allose. Now, in order to draw the pyranose structure, we need to draw the six-membered heterocyclic ring in this manner. And the carbon which is connected to the oxygen happens to be the anomeric carbon, and anomeric carbon happens to be the first carbon in case of allose also. This happens to be second, and remember second, and this is third. Third carbon is very crucial in this very case, and this is the fifth one. Now, if you are willing to draw the alpha anomer, then we know very well that in case of alpha anomer, OH group is at right side. So it should be written in downward position like this. This happens to be the second carbon. Now, in case of glucose, we know very well that OH is on left side on third carbon. But allose happens to be the C3 epimer. So OH is on right hand side in case of allose. So we need to write in this manner. This is the fourth carbon, and CH2OH must be written on upper side as we are dealing with D series. So this is the structure, I mean cyclic structure of D allose, especially that of alpha anomer. So it is alpha D allopyranose as we are dealing with what pyranose structure. Now how to draw the beta anomer of it? So in case of beta anomer, OH group is present on left side to the anomeric carbon. So let's draw the beta anomer right here. So in order to draw the beta anomer, we need to draw the six-membered heterocyclic ring in this manner. And carbon connected to the oxygen is anomeric carbon, which happens to be the first. This is second. This is third. This is fourth. And this happens to be the fifth carbon. Now, as we are dealing with beta anomer right now, OH should be written on upper side as it is present in the left hand side. and this happens to be the configuration at second, and it is clearly to be known that we are dealing with the C3 epimer. So configuration as compared to glucose, it seems to get reversed in case of allose. So beta anomer of allose can be given in this manner. So this is the beta D allopyranose. Beta D allopyranose. So this is all about the C3 epimer of glucose. Now, very importantly, let's discuss the C4 epimer of glucose. Now, what is the C4 epimer? C4 epimer is that epimer in which configuration at carbon number 4 seems to get reversed or changed. And remember, C4 epimer is popularly known as galactose. So galactose is the C4 epimer of glucose. Now this is the open chain structure of glucose, CHO first carbon. This happens to be the second, CHOH. This is third, that is CHOH. Then this is fourth, that is CHOH. This happens to be the fifth carbon, that is CHOH, and this is the sixth one. Now this is the D-glucose. Now galactose is the C4 epimer of glucose. So what happens? Carbon 1, 2, 3, 4. This is the crucial carbon. So at carbon number 4, configuration seems to get changed. So let's draw the open chain structure of galactose. So first, this is second carbon, CHOH. Third carbon, no problem with that as well. But at fourth carbon, configuration seems to get changed. This one is fifth, no problem at all with the fifth carbon, and this happens to be the sixth carbon. So 1, 2, 3, 4. This fourth carbon has reverted configuration. So this is the D-galactose. This is the D-galactose. Thus, galactose is the C4 epimer of glucose. Now let's try to draw the cyclic structure of it. Remember, it can also be obtained into anomeric forms alpha and beta. So first of all, let's try to draw the alpha anomer of galactose. So pyrano structure, in order to draw the pyrano structure, 6-membered heterocyclic ring needed to be drawn in this manner. Carbon which is connected to the oxygen is anomeric carbon, happens to be first. This is second. This is third. And remember, fourth carbon is crucial right here. This happens to be fifth. Now, if you are willing to draw the alpha anomer, then we know very well OH is at right hand side. So we need to write in this manner. So HOH. This is third one, OHH. Now, in case of glucose, OH group is at right hand side at fourth carbon, but in galactose, OH group is present on left side. So we need to write in upward manner like this. And then CH2OH should be written on upper side of the carbon number 5th, as we are dealing with sugar of D series. So this is alpha D galactopyranose. This is known as alpha D galactopyranose. Now let's try to draw the beta anomer of the same. So in case of beta anomer, hydroxyl group at anomeric carbon is present on the left side. So this is the anomeric carbon, OH group is at left, so we are writing that on upper side. Now as far as carbon number 2 is concerned, it remains as it is. Carbon number 3, it remains as it is, as the same in case of glucose as well, but at the carbon number 4, configuration seems to get changed. So we need to write in this manner. CH2OH should be written on upper side to the carbon 5, as we are dealing with the sugar of this series. So this happens to be the beta D galactopyranose. Beta D galactopyranose. So these are the epimers of glucose. We have discussed C2, C3 and C4 epimers of the glucose. Thank you very much.